Hello, welcome everyone on the lecture devoted to the life after life of underground mines. It's my pleasure to be the part of the Treasure Week of the European City of Science Katowice 2024. And in this lecture, I would like to show you some of the solutions which in future could be really beneficial, particularly for our region, a region which is of course known for the mines. Whenever you look in Silesia, you will see something related to a mine or a waste heap or coal. Well, that region is particularly known for mines, of course. But of course, as we all know, nowadays there is the energy transition which we can see, and in this regard, let me just show you a second. There we go. And in this context, of course, the mines are becoming a little bit of a problem for our region. So therefore, the question is, what could be a viable solution for all those problems, and how other countries who are already dealt with similar problems are coping with this. As you can see, the cause of the reduction in the number of mines in Europe, and of course switching into a modern economy based mostly on renewables, is related to the fact that we are increasing the energy from renewable resources in European Union. You see on this graph, if you look at it closely, you will see that the energy from renewables is increasing. Like in 2005, we had on average 10%, and nowadays it's all over 20%, getting closer to 25%. And of course, in the future, in 2030, we are supposed to have at least 30% to be in 2050 carbon neutral. So, of course, how can we do it, and what is the solution for it? Well, of course, to increase the use of renewables such as wind energy, solar energy, and so on. But on the other hand, we have to stop use the fossil fuels. And if you look also on this graph, this black line shows you the inland consumption of solid fossil fuels, which of course is a coal. And that trend is of course decreasing as you look closely into the graph. Similar trend is observed worldwide. In fact, the renewables are becoming more, let's say, popular all over the world. Now, if you look at the production of coal in Europe, you can clearly see that there are actually a smaller number or a few number of countries which in fact produce coal. In terms of a hard coal and underground mines, Poland is undoubtedly a leader, right? So as a hard coal, we mean a coking coal and a steam coal, the one which is used to produce energy, to be burned. And in this context, you can see that Poland, of course, is a leader with over 52 millions of tons of coal mined in 2023. Now, the second country is Czechia with a very small number and a little bit of coking coal, which is still mined in United Kingdom. If you also look at the global statistics, you will see that the global coal demand was pretty high in 2022, although there was a global energy crisis and we are switching into renewables. There is still in Asian country a huge demand on the coal. However, the coal production basically shifts into Asia with countries such as Indonesia, Australia, China, of course. They are still focusing and will be focusing on coal. If you look at the data related to the number of mines in Poland, nowadays we have 20 mines which are mining underground using the longwall system and producing hard coal. but the number of the mines and also people employed in the mines is constantly decreasing. Poland was, of course, a leader in coal production, in coal mining in Europe, and nowadays this trend, well, it was still a leader. Nevertheless, the trend is going down. If you look into other countries such as USA, you will also see that the number of mines, particularly the coal mines, is also decreasing. However, the trend is visible for all the mines. As you can see it in here, it's basically going down. So globally, we can see that the mines are basically closing. So we have to do something with the infrastructure which is left after the mine is closed, right? So of course, there are many reasons why we are closing the mine. Previously, the main reason, the obvious reason, is that we are running out of resources, right? So we have nothing more to mine. We do not have coal, we do not have metals. We just stop mining because it doesn't make, of course, any sense. The other important issue which we've seen in recent years is the economic conditions, right? So if the price of the resource is going down, it's decreasing because there is no demand for it, then of course there are economic reasons of stopping the mining. The other important reason is that sometimes you need to the concession for mining the coal is expiring, so coal or other resources is expiring, so we don't do it anymore. And of course, another important reason, particularly in the last years, is the environmental impact. So of course, the mines, they do have an environmental impact, such as the surface subsidence, then flooding of those subsidized areas, and all, I mean, many other reasons also related to the production of course, waste, etc., etc. So there are many reasons why the mines are being closed. Now, if you look on this picture, you will see how a closed mine looks. It's not really a nice view. But of course, there are many other solutions of what to do with it, and that's basically the aim of this presentation. So I can show you what else you can do with a mine, what are really beneficial solutions to convert an abandoned mine into a useful site. So of course, this could look like a Zollverein complex in Germany. That's the former historical mine, which was converted into a museum, a UNESCO heritage site, and that's one of the solutions which we can use to convert a mine into something which will be useful for the society, for the economy, etc. Of course, there are many other cases and solutions which we can use for using the post-mining infrastructure. In fact, if you look at the potential solutions, we can actually name 6 or even 7, although the last one is not really popular. So of course, we can use it for some commercial uses, as for conference halls, archives, restaurants, sports hall, parking lots, and so on. A very common solution is a mining museum. Probably a lot of you have been in a Wieliczka mine or a Bochnia mine, and that's the typical example. Or let's say in the Guido mine, and that's the typical example of converting a mine into a museum. You can also use it for temporary goods storage, warehouses, and so on. Of course, there are solutions to use an underground voids and underground infrastructure into a permanent waste storage, but also some specified laboratories, which I will show you an example in a minute, and temporary storage of oil or gas. Yes, gas is also another option. Now, in the last part of the lecture, I will also tell you a little bit about the possibility or the potential of using a mine as an energy storage. So, what are the benefits? Because, if you want to do something which is not really a common and ordinary thing to do, you need to give some benefits of using such locations. If you see, if you look closely at the map, you will see that, of course, in former times, mines were the center of, let's say, a modern civilization, right? So a lot of people were coming to live in the areas where you had resources, and then the cities were growing, they were building up. Many wealthy people were starting new businesses. So therefore, in most of the cases, they are located in urban areas which could be easily developed into something which can make a profit. The mine openings or the mine voids can be a significant resource when you look at availability of particular areas. This could be a good option in urban, densely populated areas, such as, let's say, Silesian coal bases. But countries like Japan, they are a good example where land is really worth a lot. Now, there is a low cost associated with using a post-mining infrastructure because you already have all the geological information which you would need. Of course, the geological surveying and later on developing some underground voids, tunnels, or galleries, that of course is associated with a relatively high cost. So therefore, if we already have all those voids and access to them, that makes this whole solution and the use of those voids much cheaper. Since they are located in some urban areas, you can also use them for waste storage. If you use industrial waste or construction waste, that's not really a very harmful thing. You can easily use them for storing some waste. Either it will be a permanent storage or a temporary storage for a number of months, years, and so on. Another, I think, important factor in using the post-mining infrastructure is the fact that it is, in fact, a pretty safe solution, right? So you are somehow isolated from external factors. So there is no impact of weather conditions, at least not a big one. So there's usually a constant temperature in a mine. There's also a constant humidity for most of the time. Of course, they are isolated from the weather conditions, and then, of course, they are isolated from, let's say, terrorist attacks. So that's also an important issue. If you want to have something in a very quiet place, which has a barrier from the external factors, then underground voids are a good solution. And I will show you how actually you can use those spaces. In fact, although many people think that mines are mostly or can be mostly converted into museums, that's not really true, because there are many other solutions what you can do, right? So even in Europe, there are many other uses of coal mines. So in Finland, they were making some experiments. They were doing some experiments in trying to keep the compressed air in the mines. In France, storing of oil, that would be also a good solution, something which is an alternative for storage of oil in porous structures, such as depleted oil or gas reservoirs. Of course, one of the most common things is to convert it into a museum, but also into some chambers where you can grow mushrooms. So a typical example, which you of course might know, is the Wieliczka mine. That's the UNESCO World Heritage Site. It's of course pretty large, a very popular touristic site. The second, let's say, most touristic one in Poland would be a Bochnia mine, which is located pretty nearby from the Wieliczka mine. And this is the typical example which we can use as that. However, I want to show you some unconventional ones, which I think are really interesting. So let's say in Santa Brigida in Italy, they use the underground chalk mine, right? So the chalk which was produced, let's say, to make chalks for the blackboards. they used it for growing mushrooms. So you can imagine that there is a constant temperature, there is a constant humidity, or you can easily adjust the humidity to a level which you want. And that was done at the depth of a few hundred meters. So it was not really a very shallow, a few dozens meters. As you can see, there is a deep which goes from the surface, so there was no need to use a shaft, a conventional shaft. And the same case is in Aosta in Italy. So there is a factory of Fontina cheese, and they use the ancient copper mine for cheese maturation. So they even use, as you can see, the railway from the old mine to move the cheeses on the shelves, and they keep them for 12 months until they are good and they can be sold commercially. Not many people know, but in Poland, one of the workings or the galleries of a mine are used as a bad natural reservation, and that's actually an old gold mine in Lower Silesia, in Wielisławka, and those old cavings were used or are used by bats. They are inhabited by bats, and that could be also a solution to have some kind of natural reserve for some animals. In United States, they were experimenting with many solutions for underground mines. There is a list. I will show you a few examples. So as you can see, in one of the salt mine, they were trying to store crude oil, use a limestone mine to keep frozen food. One of the nice examples of using the mines, especially limestone mines, is to use them for commercial and industrial uses. So basically, as warehouses, as offices, and so on. And there are two examples which are really a great representation of what can be done to old mine workings when you have a good access to them. So there is a Wampum storage in Pennsylvania, a limestone mine which was used until the 1950s. And of course, the limestone mines, they are characterized by a pretty low humidity. There's not much of the inflow of the water. In fact, they are usually in some pretty hard rocks, so you don't need a very sophisticated roof support. And since you have 60% of the humidity and a constant temperature of 18 degrees, it is used as a parking lot. So if you have old cars, you can basically keep them over the winter, or you can just rent a space and store some goods for your shop, for your business, and so on. The largest, in fact, underground complex which is in use nowadays is the Subtropolis. And the Subtropolis is located in Kansas City in USA. That's approximately 50 meters below surface. That was also a former limestone mine. And this complex has an area of 4.5 kilometers. So basically, what you can do is you can rent a space and either start a business or just keep your things for the business as a temporary goods, as a temporary storage, or you can keep the car for the winter, or keep a van or RV for storing it over the winter. And I think it's a really good example of how you can commercially use some post-mining voids. Of course, for that you need some beneficial conditions, right? So it cannot be too deep. It needs to have a pretty strong roof support and so on. Another interesting example is the Bulby Underground Laboratory. So that's the laboratory which is located in one of the deepest, or the deepest mine in England. That's over 1 kilometer below surface. That was a polyhalite mine. An interesting fact is that it's an active mine, so right. So in the part of the mine, what they do is they mine salt, basically, right? So there are many types of salts. That's why it's a polyhalite mine. And in the other part, they just started a laboratory where you can rent some spaces for specific experiments. I mean, some of the scientific instruments, they just need to be kept quiet. I mean, you cannot have an impact of changing weather conditions, humidity, vibrations from cars, and so on and so on. So therefore, it's a very nice place to create those laboratories, right? To rent the spaces for things like that. So, of course, another solution, a typical solution, would pops in your mind when you think of a mine or all the mine workings, is the fact that you can basically put some waste underground and you just forget about it, right? So that's what they do with radioactive waste. So there are many intentions to actually use mine as a waste for as a nuclear waste storage. However, there are other experiments, well, not only experiments, but industrial uses of mines where you can store waste. So basically, potash salt mines, they are used mostly to storing solid waste. Iron mines as well, they have a pretty good strong roof support. If you think on reservoirs such as gas and oil reservoirs as a mine, because they are also, in fact, the mine workings, you can use you can store gaseous waste. Coal mines, the same thing, either permanent storage of solid waste or carbon dioxide. And in some of the salt mines or caverns, there were experiments to store drilling waste, which is also a problem in some of the cases. So in Germany, for example, in a potash salt mine, there was a test to store radioactive waste. This is pretty difficult because you need to really fulfill a lot of environmental constraints to store radioactive waste. So I haven't heard of the place where they did it as a commercial activity. It was rather a test and experiments, pilot plants, rather than the industrial full-scale facilities. In many of the mines, and that's of course in mines in Poland as well, you can easily store fly ashes from power plants. So in Polish mines, at least, this is considered as a safety issue. So you want to have a better flow of air in the longwall, and therefore you use the mixture of fly ash and water, and you just fill the voids. But in fact, it's nothing more than a storage of waste, of waste from the power industry. In other places, such as in Japan, they also did the same thing. They were using fly ash. In India, Italy, store of industrial waste. Construction waste is a pretty good thing to consider to be stored in underground mines, but also some chemical waste and so on. Like a good example of how it can be done in a very, let's say, sustainable manner are two facilities in Germany. So one is the Heilbronn salt mine in Germany. So they do it for many years. I think they do it over 30 years. So there are some waste acceptance criteria. So of course they cannot be self-combustible, self-igniting, explosive, and so on. Liquid waste or gaseous waste is pretty difficult to be stored. So therefore, usually as a waste stored in mine, we do consider a solid waste. And as an example, contaminated, let's say, soil, so soil with some impurities, could be stored underground if you cannot reclaim it. Construction waste, as I said, slag from waste incineration, that could be also a good place to store, or foundry residues, that's all stored in Heilbronn salt mine in Germany. So another place which actually is a part of a big company which produces fertilizer is Herfa Neurode, which is a mine which belongs to this company, and as a waste produced from the fertilizer production, they use this waste to store it underground. So How they do it, I mean, just in a nutshell, I will show you how this can be done, so that even if something goes wrong, you can later on easily retract the waste and try to, let's say, reclaim the underground mine. So of course, first of all, the caverns where you want to store the waste, they have to be well prepared. So they do a cleaning of the roof, they do the cleaning of the floor, they level it, right? They compact it. Then before the waste is placed in underground voids, they do an acceptance control, so they really check what they are storing. So it's not like they just dump everything what they have from the surface into the mine. So it has to be really carefully checked and verified whether it's a correct waste and it fulfills the criteria which they do have in the mine. So they move them into particular parcels inside the mine. Then they store it, right? So you see they just use an ordinary construction equipment to store it. They usually store it either in a big, let's say, cans or in a big bags, because as I said, it's mostly a solid waste. And then they wall off them just to protect, so that it does not fall over the wall. So of course, the waste and the place in the mine where they locate those wastes, which, as you can see, they are in a container. It's not like a waste which you just dump there. It's all well described. You can see it here that they have like a parcels where a particular type of a waste is stored. So it's not like a mixed type randomly. It's just a well designed, well planned place of storing the waste. So in case when something happens, you can always go there and just pick it up or neutralize the waste and so on. So that's what you can do with the conventional approach towards the mines. Now, of course, there are many other questions and factors which can impact the fact that you can use the mine for a particular purpose. This is not the lecture about the mining methods, but just to give you a brief outlook on them, there are two major, let's say, mining methods. So one is the room and pillar mining, that's usually used for mining metals, ores, that kind of resources. And that method, it's not really effective because actually you leave approximately almost 50% of your deposit of your resources underground, because you leave a pillar, right? You leave a pillar which supports the roof, and then you use the roof bolting method to make this roof stable. It's not really a very quick method. However, in ore mining, that's a dominant one. So in Polish copper mines, they use the a room and pillar method, which is the most, let's say, effective, known, etc., and so on. In coal mining, on the other hand, you use a longwall mining method, and that's a very effective method because that allows you to use almost 80–90% of your deposit of your reserves, right? It's a pretty, let's say, relatively quick method because you use a longwall shearer, which basically scraps the coal constantly, and then it's transported with a belt conveyor and so on. However, what happens in this part, the roof, which is left there, it immediately, in fact, collapses, right? So there are not like regular shapes which you can use to store something, which you can use later on. So only the roads, the roadways which are used to access this part of a longwall can be used for some kind of storage. In room and pillar mining, in mines like a limestone mines or salt mines, those empty spaces, they can be used for a long time because they will stand still for many years. So a preferable option for solid waste storage, and in most of the storage cases, would be a room and pillar mining. But what else can we do with underground mines? Well, that's a good question, and that's the solution which we are developing at the Silesian University of Technology. So you can basically try to store energy. So that's a very, I would say, a broad subject on how to store energy, right? So I mean, there are many methods. I tried to summarize them in this table. So the typical ones which you can imagine would be mechanical methods. So of course, the most popular method of storing energy on a large scale is the pumped hydro, right? So you have a reservoir, the upper reservoir, the upper reservoir, and then you have a lower reservoir. So you want to fill up the upper one when you don't need an energy, and when you need an energy, you just basically release the water from the upper to the lower, and then you can produce a certain amount of energy for some time period. And that's of course the most common one, the simplest one. But there are also other energy storage systems or technologies like compressed air energy storage. There's something wrong with my mouse. Just a second, I will switch into. There is also a gravity storage, right? So you can imagine that you just lift some kind of a weight, and to lifting the weight, you have to spend a certain amount of energy, and that's the surplus energy which you can have from renewables. And then you just drop this weight and you produce energy when you actually need it. So those options, I don't know why I cannot use anything to basically, just a second. Oh, there we go. If I use, I could use actually those technologies, the gravity storage. Also, if you think wisely, you could also use a hydrogen. Oh, sorry, hydrogen. Oh, there's something wrong with my pen. Yeah, definitely. There we go. Okay, I will not play with it. I will just use my laser pointer. So you can use the hydrogen and methane. There we go. Now I can erase it. So there is no zoom bombing, hopefully, going on. But you can use hydrogen, methane storage, other power-to-X technologies in underground mines, but also you could also think of heat storage in underground mines. Okay, so the pretty common method is the compressed air energy storage, and it's a simple solution in theory, of course. So basically, when you have some kind of extra energy, you use an electric motor to drive a compressor, compress the air, pump it into an underground salt cavern, the same one as we use for storing the gas. And then when you need the energy, what you do is you release the air, it goes into turbine, which is fueled by natural gas, and then it goes into a generator, and you generate the electricity. That's the simple approach. Now, of course, many of you probably have seen compressors, which can be found everywhere, but not many of you have heard that there are like really big plants used for storing compressed air energy. There are two actually plants in the world. One is in Germany, and that one uses two solution mine caverns, approximately 300,000 cubic meters, and that uses the pressure between 40 to 80 bars. The other plant is located in USA. The similar approach. The difference is that in Hunter they use it for short charging time, so basically a few hours, and in Macintosh for long charging and discharging time. You can see that the efficiency of those plants is not really high, so it's 54, 42%, which means that basically 50% of the stored energy is wasted. And why is that, right? So why the system is not really effective? Well, the major thing behind this concept is that when you are compressing something, you have the gas heats up, right? So that's something which you which you see pretty commonly everywhere. And when you heat it up, it can be heated into a very high temperatures, even up to a few hundred degrees. So you cannot store a hot air somewhere underground in a salt cavern, because that contributes to a faster response of the salt cavern and creeping and so on and other processes. So basically you have to cool it down, right? So to cool it down, you need some additional energy. And then when you are expanding this air, right? So when it goes out of the cavern, it's decompressing. So when it's decompressing, when the pressure drops, then it cools down pretty quickly. So there is this problem that the heat loss during the compression the heat is lost during the compression stage, and on the other hand, when you are decompressing, you have to heat it up before it enters the turbine. So how can we deal with this problem? So we need to what we can do is we can separately store the heat, right? So when you are compressing it, you have a hot air. The hot air passes through a thermal energy storage, so the heat energy is stored in here, and then a cooled air is stored in here. And if you want to discharge the system, so if you want to use this energy, it passes again through this thermal energy storage. It heats up and goes into an expander. So that's basically the basic idea of the adiabatic compressed air energy system. Did they do it in reality? Yes, they did. There was a project which was called ADEL. So they had to construct those heat storage tank on the surface, and that costs a lot of money. So they spent much more than they planned. And what happened is that they had to stop the project, and they are thinking about something else. And one of the solutions was, let's say, invented by our team, and I will tell you in a minute. Now, I told you about all those salt caverns where you can store compressed air, but the question is, can you store gas in a mine, right? We all know that mine is not really a very particularly isolated system. It's not really well sealed off from the surface. So can you do it, right? So did somebody try to store some kind of a gaseous waste or whatever in a mine? So the answer is yes. So there were like actually 3 commercially operated natural gas storages in the mine. 2 of them were in Belgium, and 1 of them was in Denver in Colorado. And you can see that the storage volume of those mines was really high. So it was really a considerable space to store natural gas. And in Poland, in Nowa Ruda, that was an old coal mine in the Lower Silesia, they did try to do it as well. There was also a project Norton in USA where they were trying to do it. So that's the example of the mine in United States. The Leyden mine, as you can see, that was 1,500. Well, I think it was in feet, so that was a bit shallower, 3 times shallower. But anyway, they did use the voids to store the natural gas, and the natural gas was also stored in the coal. Okay, so I told you a little bit on the compressed air energy storage. I told you about the mines. So what could be another solution to combine those 2 ideas and to store energy in a mine, right? So what could be a good solution? So that would be a mine shaft, in fact. So that's the concept which we are developing within our group, which is called Group for Energy Storage Technologies. It's the interdisciplinary group at the Silesian University of Technology. I'm cooperating with my friend, with Professor Bartela, on developing some concept for energy storage and using post-mining infrastructure for energy storage. So the concept which was developed is based on an idea of adiabatic compressed air energy storage. So we already applied and acquired a European patent. So the concept is simple. We have a mine shaft, as you can see it in here. Then we have a thermal energy storage, and the hot air passes through the thermal energy storage. It heats it up, and then a cooled air is stored in a space between the shaft collar and the thermal energy storage. When you want to release the gas, when you want to release it and direct it into a expander, well, you do something reversed, right? So this is the space where you have a nicely chilled, compressed air, let's say 35 degrees, something like that. So you want to release the gas, you open the valve, and then that's where the heat is lost. And then during the discharge phase, what you do is you pass the cooled air through this thermal energy storage. The air heats up during the discharging and it goes into expander. Now, if you want to compare, let's say, the volume, because of course in large scale energy storage, the larger the volume, the more energy you can store. If you compare the volumes of those shafts, you can see that in a very deep shafts you have approximately 63,000 cubic meters, and in those existing plants where they store compressed air energy, it's approximately 300 to 500,000 cubic meters. Now, you can imagine that, of course, one shaft is not enough. So what can we do then? Of course, what we can do is we can use part of some of those workings which are around the shaft, or what we can do is we can basically use other shafts, right? So, I mean, it all depends on the construction of the shaft. It has to be really sealed, and it has to be really airtight to store the energy. So that's basically the visualization of the concept we do have. So this is, you see, the thermal energy storage, which is suspended in the shaft. That would be in the upper part, and the rest is filled only with the cooled air, as you can see here. There are some other visualizations made by one of our colleagues, Dr. Sebastian Wanicek, who is also part of the guest team. And you wonder, okay, why don't we use some more shafts? No problem. We do have an inventory of the shafts in Upper Silesia, in the whole Poland. So in Upper Silesia, there are over 172 mine shafts. So only in Upper Silesia, whereas in the whole Poland, including the copper mines on the west, it's over 222 mine shafts. So there's a lot to choose from those shafts. Does this idea has any sense? Well, we do think it does have a sense. If you look at some historical experience, well, not historical, but the current one, there's also a project in Switzerland. I mean, you know that the Swiss cannot be wrong, where they use, let's say, a similar concept, but it's not vertical, but it's rather horizontal, right? So they use a tunnel, basically. It was a tunnel, an excavation in a mountain. And they already did some experiments. This is basically the part where you store, that's the part where you are storing the heat. And the first trials were pretty successful. 120 meters of a tunnel was used for the test. So there are many benefits of this concept, and that's of course a part of the project which we are nowadays carrying out. So it's a project related to the hybrid energy storage system funded by Research Fund for Coal and Steel. So many benefits of the concept. Of course, there are many problems related to it, right? So of course, in the coal mines, you might have methane, and that would be one of the big problems. The other problem is that if you have air and it goes into contact with coal, then the coal is prone to self-combustion, basically, right? So, the fire can be done by itself. I mean, you don't need any kind of ignition. So the other problem would be, of course, the air tightness, let's say, right? So the normal, as I mentioned, the long wall method, what happens is that this is the coal which you mine, and then you leave the empty space, and then it all collapses. And what happens is that you have cracks and fissures which propagate up to the surface. A few words about other concepts. So, of course, you could imagine that you can use mines for storing energy in the form of the pumped storage hydroelectricity, right? So instead of doing this on the surface, you use the underground voids as a lower reservoir, and then a surface lake or a pond or you can try to use also some kind of galleries which are shallower for the storage of water. I mean, there are other concepts, like this is one of the concepts from Germany, but there will also some trials in Poland. SRK, they have a small installation where they try to recover energy from water. You could have in the closed system, right? So you basically pump this water on and on from top to the bottom. From bottom to the top, or you can have an open system, which does not really work. In Spain, they do also work on those ideas. So they are analyzing whether to start such an energy storage concept in Asturias, in Spain. Many publications and projects are being carried out on this concept. And another interesting concept, which was invented in UK, a pretty simple one, is that you basically use a shaft to suspend a weight. You suspend the weight, and then if you need energy, if you have surplus energy, so you have some more energy than you need, you just basically lift it up. And then when you need the energy, you lift it. You just drop it down, of course, pretty slowly. And then you use some simple generators to generate electricity. There is a startup company which is developing this concept using basically the cranes which are used in shipyards. So that's one of the solutions which could be done. So I see that I've already passed my time. Thank you for your attention. I hope that was something interesting for you, and you enjoyed the presentation. I don't know if we can ask questions because I don't see anyone else on the Zoom. It's streamed on YouTube. So if you have any questions to me, just mail me. And I'll try to answer them. Thank you very much. Have a nice evening.